Hello, good afternoon, and welcome to the poster presentation session. So, as you can see, actually the posters are pre-recorded and by me and Mehran, so it's not really professional, but we did our best. So the poster were presented by our team on different topics on renewable energy powered membrane system, on osmotic backwash, on nitrate, arsenic, or inorganics in general removal with nanofiltration and electrodialysis, on the micropollutant removal. And here talking about the hormones. Also, the photocatalytic membrane will be presented by Roman and Shabnam, and then the carbon-based nanoparticles incorporated in membranes will be presented by Minh and also Phuong. So here I will start the video. It's a 20-minute video, so 10 posters. Hello everyone, and welcome to my presentation, which is about the resilience of photovoltaic power membrane filtration system for fluoride removal from brackish water. So the motivation behind this work is that the renewable energy power membrane system can be a cost-effective solution to address water scarcity, especially in remote regions. So for this, we have investigated the performance of a PV membrane system without battery. We have quantified its resilience, and also we have determined the correlation between the yield line electrical conductivity sensing and fluoride concentration in this case. So we have investigated for Tanzanian water characterized with high fluoride concentration, can go to up to 60 milligram per liter. We have done the filtration experiment with the PV membrane system, and in which we have input identical solar radiation quality thanks to a solar array simulator. And this solar radiation data exhibit a fluctuation period. In this case, is the clouds. And we have operated three membrane NF270, NF90, and BW30. So the performance of this system have showed like that the differences in permeate production and specific energy consumption mirror the flux variation. And the salinity removal with the loose membrane, in this case NF270, was more affected by fluctuation. So the resilience factor in this case is the ratio between the initial performance and the performance during fluctuation was more affected by the membrane choice, and we were able to correlate the fluoride concentration and the EC data. So for the highlight, the system is the resilience of the system more depend on the membrane type. The loose NF was more resilient to specific energy consumption variations, and the EC sensing can be correlated to fluoride concentration. Thank you.
Hello everyone, my name is Yang-Hui Cai. I'm a PhD student in IAMT. Welcome to my poster today. The title of my poster is Renewable Energy Powered Membrane Technology, Impact of the Osmotic Backwash on Mineral Scaling. And why we focus on mineral scaling? Because scaling is the key limiting factor for the membrane desalination process. And we find the osmotic backwash process due to the solar energy fluctuations could be a potential cleaning method to control the scaling. So in this project, our research aim is to investigate the feasibility of the osmotic backwash for the membrane scaling control. And we use two common commercial membranes, the MF270 and BW30, and we use two very common scalene, which is calcium sulfate and calcium carbonate. And we use this left scale cross-flow system powered by the solar energy simulator. And we also monitor the osmotic backwash performance during the experiments. What we find is the calcium sulfate scaling is more serious than the calcium carbonate scaling. And we also find here, as you can see, the flux recovery after the osmotic backwash for the concentration correlation is almost 100%. And then the second best is the surface crystallization, and it's not so effective for the bulk crystallizations, as you can see. So what we find is the solar energy fluctuation induced osmotic backwash can remove partial scalant and recover like 30 to 96% flux. So we conclude that this osmotic backwash process can act as a neutral self-cleaning method in directly coupled solar energy powered membrane systems. And if you are interested in this project, you can look for our papers. Thank you for your listening.
Hi everyone, I'm Mehran Aliaskari. I'm a PhD student at the Institute for Advanced Membrane Technology in KIT. This is my poster presentation. The topic is nitrate, arsenic, and fluoride removal by electrodialysis from brackish water. So the motivation for our work is that these three contaminants, nitrate, arsenic, and fluoride, contaminate groundwater resources in saline waters in arid and semi-arid countries where these waters are where it is necessary to use these waters for drinking purposes. So what we investigated and what our aim was that we wanted to investigate the extent of removal by different parameters, by changing different parameters, so operational and water quality. And by doing this, we could understand the most important parameters and mechanisms in ion removal in electrodialysis. To do this, we used the bag system. It contained of 3 tanks, 5 liter each, and we used AMX membranes, anion exchange membranes, and CMX cation exchange membranes. And yes, we used IC for nitrate and fluoride, and ICPMS for arsenic 5 analysis. So we go to result. When we changed the pH of the solution, nitrate and fluoride removal did not change. However, the arsenic removal was very dependent on the pH. We could explain this by the mobility and diffusivity of arsenic as it gets lower in higher pH and its hydration number that is increased in higher pH. When we go to salinity, we saw again the same effect on arsenic 5. A little bit on fluoride, but on nitrate, because it has the same mobility and diffusivity to chloride, which was our main salt, it was not affected. And the last one is electric potential, and that we investigated, and as we increased the driving force, which is the electric potential, from 5 volt to 25 volt, nearly all the ions were removed better. So in the end, the conclusions are that the most important parameters are the ionic characteristics that are shown here somehow in this highlight, and also the driving force. So as we go above 15 volts, the removal of all ions are increased. Thank you very much for your attention, and I'm waiting for your questions.
Hello everyone, welcome to my poster, which is about removal of arsenic by nanofiltration, role of organic matter interaction. Arsenic is a big problem around the world, especially in developing countries. The arsenic can coexist with high salinity, which is due to seawater rise in coastal areas such as Bangladesh, and also arsenic contamination or mobilization is also correlated with the presence of organic matter. So for this, we have investigated the impact of salt on arsenic removal with nanofiltration, the presence of organic matter, and thus we have investigated if there is a possibility of interaction between arsenic and organic matter that may enhance the retention. For this, we have investigated two nanofiltration in F90 and F270. We have used hand-use coupled mass spectrometry coupled with flow field flow fractionation, FFF, to investigate the arsenic and humic acid complexation, and TOF seems to investigate the attachment of arsenic on the membrane in presence of humic acid. For the filtration experiment, we have used the cross-flow filtration system with a fixed period flow rate. So the results have showed that arsenic rejection was not affected by salt variation, and however for the pH variation, the experiment showed that rejection of arsenic 5 is actually higher than arsenic 3, and the arsenic 3 rejection with NF is pH dependent comparing to the arsenic 5. So for the humic acid experiment, the FFF ICP-MS showed that with increasing humic acid concentration, the interaction between humic acid and arsenic increased, which explained the high removal of arsenic in the presence of high concentration of humic acid. And the top seams analysis has showed that humic acid enhanced the presence of arsenic in the NF270 membrane active layer. So for the conclusions, the arsenic rejection with NF is regardless to salinity. Arsenic 5 speciation does not affect NF performance, and the humic arsenic interaction was quantified with FFF ICP-MS. Thank you.
Hello, my name is Alessandra Imbrogno and welcome to this poster, which is about the comparison of membrane characterization devices and breakthrough phenomena at different scales. So what we did here was to compare the nanofiltration performance in systems of different design, the detailed sterile cell and 2-cross-flow system, and different scale dimension of the membrane module. So we started from a very little membrane module in the micro-cross-flow that has just 2 square centimeter membrane area, and then we scaled by increasing the channel length of 20 times, and we used the macro cross-flow system. The increasing of the channel length, of course, produced different hydrodynamics and concentration polarization in this system, which affected the nanofiltration performance. As you can see here, for salt retention, we observed the lowest sodium chloride retention in the macro-cross-flow system due to higher concentration polarization. For comparability of molecular weight cutoff of this membrane, we adjusted the operative condition in such a way to minimize the concentration polarization, and as you can see here, we got comparable results in different systems. If we move now to the estradiol breakthrough curve, you see here that the breakthrough curve shape is different in cross-flow and in sterile cell, and this was because in the sterile cell we concentrate the hormone solution during the filtration process, while this does not happen in the cross-flow system. And then again in the macro cross-flow, which is the system with the highest concentration polarization, the breakthrough curve changes when we change the operative conditions like the pressure. So I want to highlight with this poster that concentration polarization is a very important parameter to control if you want to achieve comparable membrane performance in laboratory scale devices. And this is especially relevant if you characterize new membrane material that you don't know the performance at the beginning. So you need to watch the operative conditions and the concentration polarization. Thank you very much and welcome for questions. Hello, my name is Alessandra Imbrogno and welcome to my poster. The poster is about the macropollutant partitioning in combined magnetic ion exchange membrane process. So what we did was first to evaluate the applicability of these magnetic ion exchange resins to control folding of nanofiltration membranes, and then we wanted to quantify the partitioning of estradiol as example of steroid hormone macropollutant in this complex system. So in the method, we used the Myx resins directly in the feed solution, and we did a one-step filtration. And in the feed solution, there were also the estradiol and the humic acid. And as you can see here, we could control very effectively the folding of nanofiltration membranes due to the strong Myx-humic acid interaction. And this occurred at both acidic and alkaline conditions. However, as you can see in these two figures, there was a significant estradiol uptake because of the interaction with the Myx, and we could see up to 40% of the mass loss. So in this poster, I want to highlight that the estradiol-Myx interaction is significant and causes uptake of these hormones in such a complex system. And this poses an environmental risk because the estradiol is weakly bounded, so can be further released during the regeneration process of the brine or the membrane cleaving. Thank you very much for your attention and welcome for questions.
Hello, my My name is Lyubimenko. I'm a PhD student. The topic of my work, porphyrin functionalized membrane for visible light-driven pollutant degradation. The micropollutant removal is a major problem in the water treatment technology because it can be found in the microgram per liter to nanogram per liter concentration in surface water. To avoid the accumulation of the hazardous solids and liquid waste, we can perform the oxidation by membrane-immobilized photosensitizers by producing the active singlet oxygen. In this work, we fabricated the porphyrin-coated membranes that are active in the visible light range and they produce very active and selective singlet oxygen. For this, we use the photostable and hydrophobic fluorinated porphyrin that are immobilized by the method of adsorption and tested in the photocatalytic membrane setup that can be equipped with different types of light sources. For separation and detection of the steroid hormone micropollutants, we developed a method based on the liquid chromatography and flow scintillation analysis of radio-labeled steroid hormones that allowed us to detect down to 2 nanogram per liter concentrations. Notably, we proved that the membrane is coated internally with porphyrin by conducting toxins analysis, which showed that up to 60% is loaded inside, and by conducting the photoluminescence study, we showed that we can produce active singlet oxygen. That led us to conducting the experiments with different steroid hormones that exhibited up to 80% removal of estrogenic steroid hormones. Unfortunately, testosterone and progesterone were more resistant to degradation because of their structure that do not hold the phenolic core. Finally, we conducted a set of experiments for determination of rate limiting step by conducting the studies of the E2 concentrations, water flux, and light intensity. As a conclusion, I would like to say that the fabricated porphyrin-coated membranes are effective for degradation of steroid hormones in single pass, continuous flow, and can be achieve the degradation in a second scale. For more information, please address our recent paper. Thank you.
Hi, my name is Shabnam Lotfi and I would like to present our work to you. Presence of micropollutants in water is a great concern for both aquatic life health and human health. It causes different problems like fertility issues or fish fertilizations. WHO has proposed 1 nanogram per liter concentration for estradiol in drinking water, which is a natural steroid hormone. Currently, conventional wastewater treatment plants and water treatment plants fail to remove this, and the question is that what should we do now? Fortunately, some advanced technologies like advanced oxidation processes and membrane technology can successfully remove and degrade these compounds, and this is our motivation. We have chosen photocatalysis coupled with membrane technology thanks to their advantages like no additional chemical needed, it can work in ambient temperature and pressure, and thanks to the membrane technology, it can work in a continuous process. We have done a thorough evaluation of relevant parameters in the photocatalytic membrane reactor, including water flux, light intensity, temperature, feed concentration, pH, and hormone type. A selection of results can be seen here. At the end, we could have achieved 6 nanogram per liter concentration in the permeate side, which is close to the concentration proposed by WHO. We could achieve a high degradation in the 2.5 seconds residence time, and also we could achieve a degradation of 4 steroid hormone at the same time in a mixture successfully. Thank you for your attention, and I'm welcome for any question.
Hello everyone, my name is Minh and I'm a PhD student in Professor Schaeffer's group. Today I want to present my topics: interactions between carbon-based nanoparticles and sterile hormones for membrane incorporation. So why I want to do this? I want to treat sterile hormones in water, and I want to go for the adsorption method. And to do that with the membrane, I need to choose the most suitable nanoparticles that can absorb micropollutants, sterile hormones in water in a membrane.
So what I try to do here is I have 6 types of carbon-based nanoparticles. I have multiple wall carbon nanotubes, single wall carbon nanotubes, 2 grades of graphene, graphene oxide, and fluoride. And the results are amazing. Most of the carbon-based nanoparticles can absorb hormones very fast. As you can see this absorption kinetics here, and some of them have really high absorption capacity, such as the carbon nanotubes and graphene. However, some of them have very low absorption capacity. And to understand why, I've evaluated the surface areas that are assessed by the pollutants. So you can see here, the absorption performance is influenced by the accessible surface area, and the aggregation state of this particle in water dictates this behavior very much. And then I propose some interaction mechanism. After the pollutants access the surface area, there will be a lot of long range and short range interactions, as you can see here. The main short range interaction can be pi-pi stacking, hydrogen bonding, van der Waals, and van der Waals forces. So that's everything with this presentation. Thank you very much for your attention.
Hello everyone, my name is Phuong, and today I will present you our work about the incorporation of single wall carbon nanotubes in ultrafiltration support for sterile hormone removal. So, as we all know, ultrafiltration membrane can operate at low cost but do not retain sterile hormone. Meanwhile, single wall carbon nanotubes can, but they are potentially toxic. Therefore, in this research, we incorporate single wall carbon nanotubes and ultrafiltration membrane to remove sterile hormone. We also investigate the impact of operating conditions and water chemistry on the absorption mechanism. And finally, we determine which types of organic matter that causes the strongest reduction to the sterile hormone removal. So, in details, we incorporate single wall carbon nanotubes in the support layer of ultrafiltration membrane. And this is the pictures of how the membrane looks. And we run filtration through a microprocessor system. We change the loading of single wall carbon nanotubes inside the membrane support layer. We change the pressure of the operating system, and we change the types of organic matters that we run through filtration. So in conclusion, the membrane setup can remove 50 to 85% of sterile hormone. However, this can be affected by aromatic organic matter, such as salicylic acid or humic acid. So, thank you so much for your attention.